The United States swiftly powered down the James Webb telescope right after it uncovered information about Mercury that NASA had kept concealed. Close to our gigantic sun, this small planet is anything but ordinary. It enthralls us with unexpected treasures, including diamonds scattered across its searingly hot surface. However, beyond this dazzling brilliance, there is a massive and bizarre core that remains concealed, one that challenges all previously held scientific predictions. What secret stories have these surprising revelations brought to light? Stay tuned if you're curious, as we're going to uncover some revelations that might completely transform everything we thought we understood about planets. Before we dive in, please give this video a like and subscribe to the channel so you don't miss out on any future content. Unveiling a surface adorned with extraterrestrial diamonds. At first glance, Mercury might appear to be just a tiny speck near the Sun, but do not be misled by its diminutive proportions. Yet, beneath this scorching hot facade, there lies a treasure trove of incredible secrets waiting to be unearthed. Recently, space probes unveiled a surprising discovery. Diamonds are generously scattered across Mercury's landscape. Diamonds on one of the hottest planets in our solar system? Yes, and that is truly just the very beginning. However, as we dig deeper, we discover that the core of Mercury is extraordinarily large and quite unusual. These startling revelations bring up an urgent question. What truly sets Mercury apart from its planetary counterparts, and what additional enigmatic stories might it still be hiding? Mariner 10 was a true pioneer, being the first space probe to ever visit Mercury. It transmitted the initial close-up images of the planet, showing a world strikingly similar to our moon's surface, abundant with craters and peculiar cliffs. This particular mission unveiled Mercury having a rugged surface, a magnetic field that was surprisingly strong, and an even larger core than scientists had originally thought, thereby challenging previous notions regarding Mercury's composition. However, that wasn't the most astonishing aspect. 31 years later, the Messenger mission, launched to further explore the planet, elevated our comprehension of Mercury significantly. In contrast to Mariner 10, the Messenger spacecraft was specifically engineered to orbit Mercury, which enabled it to examine the planet in great detail for a much longer duration. The mission captured around 200,000 images, revealing parts of Mercury that we had never observed, significantly expanding our understanding of this fascinating planet. One of the most intriguing discoveries made by Messenger was the surprisingly large quantities of both calcium and magnesium present on the planet Mercury's darker side. This discovery made scientists highly inquisitive about the natural processes that might have led to such elevated concentrations of these particular elements. They also uncovered that Mercury's magnetic field exhibited significantly greater strength within its northern regions, a discovery quite surprising when contrasted with other planets found throughout our solar system. These remarkable findings prompted scientists to realize that Mercury's internal structure and its overall development were profoundly different from what they had initially conceived. On Earth, magnetic fields are typically generated by the movement of molten iron in the core. Nevertheless, the unique internal composition of Mercury generates a distinct type of magnetic activity. What else makes the landscape of Mercury stand out even further? Beyond its craters and cliffs, the planet is subjected to extreme environmental conditions. During the daytime, temperatures on the surface of Mercury can reach as high as 430 degrees Celsius, which is scorching hot, sufficient to melt lead. Conversely, temperatures plummet drastically at night to approximately -180 degrees Celsius. This enormous temperature fluctuation happens because Mercury's extremely thin atmosphere contributes very little to either temperature regulation or heat retention. Nevertheless, the extreme temperatures are not the sole astonishing aspects concerning Mercury. More recent studies have actually unveiled some unexpected characteristics on its surface. In the year 2012, Messenger mission data revealed indications of volcanic activity, even including proof of prior explosive eruptions. This finding completely overturned the long-standing assumption that Mercury was geologically inactive. Then, in the year 2020, researchers uncovered an even more fascinating discovery. Scientists discovered frozen water in some of the permanently shaded craters located at Mercury's poles. These areas, consistently shielded from direct sunlight, remain cold enough to keep water frozen, even though Mercury is so near the Sun. The discovery of ice sparked new inquiries into whether Mercury might possess the capacity to support fundamental life forms, akin to those thriving in our planet's most extreme environments. Could it be that they survive in these cold regions of Mercury? This question sparks thrilling new possibilities for how we comprehend the potential for life to flourish under diverse planetary conditions. Yet, this is merely the beginning of the story. In the year 2018, a space probe known as Bepi was sent on its way towards Mercury. This was made possible by a partnership between the European Space Agency and the Japan Aerospace Exploration Agency. It is expected to reach Mercury by the year 2025. Upon its arrival, Bepi is set to collect comprehensive data concerning the planet, such as details about its surface and its complete geological evolution. Amazingly, despite its close proximity to the Sun, Mercury possesses a powerful magnetic field and even frozen water. However, there's something even more astonishing. A day on Mercury spans a longer duration than its year. Typically, when we envision planets, we picture them rotating on their axis daily and completing an orbit around the Sun annually. However, Mercury diverges from this common perception. Indeed, on this diminutive and extremely hot planet, one day actually spans a duration greater than an entire year. Let's delve deeper into Mercury, understanding how a single day there can be longer than a year. It's truly a symphony of sun and shadow. To put it simply, Mercury takes only 88 Earth days to complete one orbit around the Sun, making its year much shorter than ours. However, a complete day on Mercury, which is a full rotation on its axis, takes approximately 176 Earth days. This implies that one full year on Mercury actually lasts for only half a day, giving rise to some extremely unusual phenomena. If you were standing on Mercury, you would observe the Sun gradually ascending and expanding in size as it traverses the sky. However, something peculiar would then occur. The Sun would suddenly come to a halt, move backward a bit, and then proceed on its trajectory. This peculiar movement arises because Mercury rotates extremely slowly relative to its rapid orbit around the Sun. But that isn't the most unusual aspect. Why does Mercury even rotate so sluggishly? The answer lies in a phenomenon called tidal locking. Over billions of years, the Sun's powerful gravitational pull has progressively slowed down Mercury's rotation. In contrast to our Moon, which is entirely tidally locked to Earth, Mercury experiences a unique phenomenon called a 3-to-2 orbital resonance. This signifies that for every 2 times it completes an orbit around the Sun, it rotates 3 full times on its own axis. These distinctive patterns of rotation and orbit result in extreme conditions on the planet Mercury, particularly because of its peculiar day-night cycle. The sun-facing side of the planet remains extremely hot for many months, while the side facing away from the Sun stays in icy darkness for that same amount of time. This results in some of the most dramatic temperature shifts within our solar system. When we speak about the atmosphere of Mercury, it's essential to understand that it actually doesn't have a true one. Instead, it has an extremely thin layer called an exosphere. This layer is incredibly thin, perpetually escaping into space and replenished only occasionally by elements such as the solar wind, the decomposition of radioactive materials, and collisions from small space rocks. New research has brought to light some rather unexpected details concerning Mercury's exosphere. In the year 2020, findings from the MESSENGER mission revealed that Mercury's exosphere contains a greater amount of water vapor than what scientists had previously estimated. This water vapor probably forms when hydrogen from the solar wind reacts with the oxygen present in Mercury's rocks. Another fascinating aspect of Mercury is the combination of its rapid revolution around the Sun and its relatively slow rotation. This unusual combination significantly impacts its magnetic characteristics. Although Mercury is small and rotates slowly, it still has a significant magnetic field, an unexpected discovery for scientists. Additional studies indicate that this magnetic field originates from unique internal movements within its liquid metallic core, which are significantly shaped by Mercury's particular rotation and orbital path. Yet, even with its magnetic field being weaker than Earth's, Mercury's magnetic field plays a crucial role. It shields Mercury's surface from the intense solar wind. Without such protection, solar winds would continue to erode Mercury's already weak atmosphere even further. The swift orbital motion of the planets around the Sun, combined with its unhurried rotation, gives rise to several intriguing phenomena. On Mercury's surface, There are specific locations, commonly referred to as hot poles, where the Sun appears to remain stationary in the sky for a period. These areas experience extremely high temperatures. Conversely, areas near Mercury's poles are shrouded in eternal darkness. This unique condition permits the presence of ice there, even with its close proximity to the Sun. This occurs due to the unique rotation and orbital path of Mercury around the Sun. The craters within these perpetually shaded areas never receive any direct sunlight and therefore remain exceptionally cold, even while the rest of the planet is blistering hot. Scientists are now pondering whether other materials, potentially even organic substances, might be concealed within these perpetually frozen regions. The swift orbital path and the sluggish rotation of Mercury also influence the ways in which we are able to investigate the planet. Its rapid movement around the Sun makes it difficult for space probes to reach and study it. To achieve sufficient deceleration for entering Mercury's orbit, space probes are required to execute intricate navigation maneuvers, which involve several flybys of both Venus and Mercury. The Bepi-Colombo mission is currently utilizing these precise flybys in order to meticulously adjust its velocity and orbital path. Bepi-Colombo was launched in 2018 and is slated to enter an orbit around Mercury in 2025, following a total of 9 flybys. Upon its arrival, Bepi-Colombo will be confronted with Mercury's unique day-night cycle, which demands meticulous temperature and energy management for its continued operation and survival. As we delve deeper, the planet Mercury's mysteries start to unveil. It's an odyssey towards the very core of the planet. However, that is not the sole challenge that lies ahead. Recent studies suggest that Mercury may have rotated more rapidly in the past, but its rotation was progressively decelerated by the Sun's gravity and potential impacts with other celestial bodies. This revelation not only aids in comprehending Mercury's history more thoroughly, but also yields crucial insights into the development of planets within our solar system. The more information we acquire, the more new questions emerge regarding Mercury's interior and its surface. Scientists are particularly curious about its core, which, despite extreme cold, appears to be partially liquid, and also about how its unusual orbital path affects its geological characteristics. These continuous revelations keep the scientific community on the edge of its seat, as Mercury consistently surprises us and truly puts our understanding of planet formation and development to the test. What further hidden mysteries might this minuscule crater-filled planet still be concealing deep beneath its outer layer? Even though Mercury is the smallest planet within our solar system, it holds many mysteries that captivate researchers. Its diminutive size doesn't prevent it from possessing some truly extraordinary characteristics. One of Mercury's most fascinating characteristics is its enormous core. Dr. Nancy Chabot, who is a planetary scientist, conducted a study which demonstrated that Mercury's core actually constitutes approximately 85% of the planet's total volume. In comparison, the Earth's core accounts for just about 15% of the total volume of our planet. This raises a big question. Why does Mercury have such a large core? A prominent theory posits that Mercury was significantly larger previously, yet shed most of its external strata from a colossal impact early in the solar system's development. This theory, which is referred to as collision stripping, was put forward by Dr. Eric Asfog. He speculates that a substantial object might have collided with Mercury, stripping away much of its outer material and leaving behind only its iron-rich core. But the surprises of Mercury don't end here. It also possesses a magnetic field, an unexpected characteristic for scientists considering such a small and slowly rotating planet. In contrast to Venus and Mars, which lack global magnetic fields, Mercury possesses a magnetic field that is approximately 1% the strength of Earth's own magnetic field. This discovery, made by the NASA Messenger mission, left scientists puzzled. But another surprise was yet to come. Dr. Katherine Johnson and her team discovered that Mercury's magnetic field is not centrally located. In fact, it is shifted northward by approximately 20% of the planet's radius. This unusual displacement may be linked to variations within Mercury's crust, potentially influencing how heat dissipates from its core. Yet, as if that weren't surprising enough, in 2020, researchers made another discovery. Mercury's surface contains volatile elements such as sulfur, potassium, and sodium. This adds even more enigma to the already intricate planet, sparking further inquiries that are prompting fresh studies as scientists endeavor to decipher Mercury's numerous mysteries. However, these discoveries are merely scratching the surface of what Mercury might still be concealing. What other secrets could this diminutive planet potentially disclose? It's quite remarkable to find specific substances on Mercury that typically evaporate at elevated temperatures, particularly on a planet situated so near to the Sun. Dr. Patrick Poplawski from the Applied Physics Laboratory at Johns Hopkins University presents an interesting theory. He speculates that these volatile substances, which quickly transform into gas, might have arrived on Mercury much later, possibly via comets or asteroids that impacted the planet following its initial formation. One of the most incredible discoveries on Mercury is the frozen water in permanently shaded craters at its poles. Dr. Nancy Chabot, whom we mentioned earlier, played a crucial role in this research. These frigid regions remain cold because the sun's warmth never penetrates these craters, causing the temperatures there to stay exceptionally low. However, even more captivating is the discovery of organic matter found in these frozen regions. Scientists identified dark areas potentially containing intricate carbon molecules similar to those that may have contributed to the genesis of life on our planet Earth. Even with its extreme environment, might Mercury yet contain hints about the genesis of life within our solar system? Mercury still holds many more surprises concerning its geological activity. For an extended period, scientists were convinced that Mercury was geologically dormant, yet the MESSENGER mission revealed new evidence suggesting recent volcanic activity. Dr. David Rothery from the Open University in the United Kingdom made a discovery. There are small, bright volcanic vents found on the planet Mercury's surface. These unique geological features, referred to as hollows, strongly imply that geological processes on Mercury could still be ongoing. Next, we dive into the chaos and mysteries of Mercury's landscape. The chaotic heart of Mercury. One of Mercury's most fascinating geological characteristics is its chaotic terrain, a vast, rugged region of hills and valleys situated near the South Pole. This area was discovered during the Mariner 10 mission in the 1970s, and its size is roughly comparable to that of the US state of Texas. Dr. Thomas Waters from the Smithsonian Institution suggests that powerful quakes, potentially triggered by the Sun's gravitational pull during alterations to Mercury's orbit, might have formed this terrain. Recent studies have significantly advanced our understanding of Mercury's internal structure. Dr. Amir Khan, a researcher at the University of Zurich, utilized data collected during the MESSENGER mission to investigate the planet's composition. His findings indicate that Mercury, similar to Earth, possesses an outer liquid core and a solid inner core. However, the inner core of Mercury is much larger in proportion compared to that of Earth, and this might account for some of its unique magnetic characteristics. These remarkable characteristics of Mercury compel us to re-evaluate our understanding of how planets are formed and how they undergo development over time. They serve as a reminder that even within our cosmic vicinity, many undiscovered secrets still exist. As we anticipate additional missions and fresh discoveries, we can only speculate what other captivating details might be hidden beneath Mercury's surface. The latest investigations and space missions demonstrate that the enigmatic aspects of Mercury are every bit as captivating as its actual surface. The solid core of Mercury spans approximately 2,000 kilometers in diameter, comprising almost half of its total core volume. On the other hand, for Earth, its solid core makes up only about 20% of its overall core volume. These differences in size and composition are quite significant as they play a role in influencing Mercury's magnetic field. Even though this magnetic field is weaker than Earth's, it is nevertheless remarkably powerful for such a small planet. Directly above the core of Mercury, there is a surprisingly thin mantle layer. Scientists now believe this mantle is only about 420 kilometers thick, much thinner than Earth's mantle, which is almost 3,000 kilometers. This thin mantle layer affects Mercury's geological activity and the way the planet distributes heat. But there is even more to it. Mercury is more than what appears at first glance. In the year 2012, the MESSENGER mission discovered evidence of past volcanic activity on Mercury. The probe located shallow, distinct depressions called hollows that emerged as volatile materials on the surface evaporated. This implies that Mercury could possibly hold a greater abundance of these volatile materials than we had previously imagined. Then, in the year 2020, scientists once again analyzed data from the MESSENGER mission and uncovered indications of a tremendous magma reservoir that previously existed below Mercury's surface. This ancient magma ocean likely played a crucial role in forming both the planet's surface and its deeper geological layers. This magma ocean helps explain why Mercury's surface exhibits vast, smooth plains, particularly across its northern hemisphere. These areas, specifically recognized as the northern volcanic plains, were probably shaped by immense lava flows during Mercury's early stages. Yet, the astonishing discoveries continue beyond this point. In 2022, investigators unearthed even more hidden secrets lurking beneath Mercury's rocky exterior, revealing that this planet continues to hold a wealth of untold narratives. Scientists, after examining data from the MESSENGER probe, uncovered indications of nitrogen confined deep within Mercury's subsurface. This nitrogen might be a leftover from a former dense atmosphere that was driven underground by the planet's intense heat and continuous solar radiation. This discovery raises exciting questions about Mercury's past. Did the planet once possess a much denser atmosphere? What does that reveal about its primordial conditions? And might it possibly have once harbored actual traces of life? Mercury also possesses frozen water, concealed within the perpetually shadowed craters located at its poles. Even though this ice is situated on the surface, it stays protected from solar radiation and is conserved by the intense cold of these shadowed regions. Indeed, recent studies suggest that some of this ice is relatively recent. It might have been delivered to Mercury by comets or asteroids within the last 10 million years. Now, let's look at the clues that indicate Mercury continues to evolve, unveiling its geological secrets even today. It is believed that these dark patches located within the polar craters also contain organic matter, which may have been delivered by the very same space impacts. This organic material, which is less stable than ice, presents a unique opportunity to investigate how organic molecules are distributed throughout the innermost regions of our solar system. Mercury's subsurface features also tell us a lot about its geological history. In contrast to Earth, Mercury lacks tectonic plates, yet it exhibits distinct evidence of contracting over time as it underwent cooling. This is evident from many geological faults on its surface, where crustal sections have been thrust over each other, sometimes reaching several kilometers high. These faults reveal a lot about Mercury's internal composition and geological past, but this is where it gets even more exciting. Additional investigations into these faults indicate that Mercury may still be geologically active today. A study published in 2019 discovered evidence of tectonic troughs, which are small valleys formed by the stretching of the crust near some of the planet's most significant faults. These particular features appear to be relatively recent, indicating that Mercury's crust is still undergoing transformation. And then, there is the magnetic field of the planet, which is quite different from that of the Earth. While Earth's magnetic field is generated by the movement of molten iron in its outer core, Mercury's magnetic field might come about through an entirely different process, sparking even more curiosity about the formation of magnetic fields on other planets. Researchers are now exploring the exciting possibility that Mercury's magnetic field is caused by liquid metal flowing around its solid inner core. This process is very similar to what we observe on other planets and even stars, indicating that Mercury has a surprisingly complex and highly active interior. However, there's still much more to uncover. Scientists are also highly curious and very interested in what lies beneath Mercury's surface. They speculate that there may be numerous cracks and fissures beneath the crust. This might enable the circulation of heat and potentially even liquids among the diverse layers within the planet. This concept proves particularly fascinating as it suggests that Mercury, once considered geologically dead, could still possess some active processes within its interior. Even though Mercury's surface currently appears dry and barren, some researchers hypothesize that water reservoirs could be concealed deep within its crust. Should these reservoirs truly exist, they might either be relics from an era when Mercury enjoyed a milder climate, or perhaps they are sustained in a liquid state by the planet's significant internal heat. This concept mirrors what's observed on moons such as Europa and Enceladus, which feature concealed oceans beneath substantial ice layers. This discovery truly challenges our current understanding of where life could possibly exist in the solar system. The potential discovery of water on Mercury has the capacity to spark extensive new research into the planet's history and whether it once fostered conditions essential for supporting life. Should water be discovered, it could yield vital insights into Mercury's geological past, while also prompting new inquiries into the chemical reactions occurring beneath its surface. However, our interest extends beyond Mercury alone. The study of its interior helps scientists to better understand how rocky planets like Earth originated and developed. Grabbing a firm grasp on Mercury's geological past, its volcanic activities, and the very composition of its core is absolutely essential. This allows us to form a comprehensive understanding of how planets within our solar system, our own Earth included, have truly evolved throughout history. Every new discovery about Mercury expands our understanding and provides fresh insights into the early history of our solar system. For instance, investigating trapped gases and other materials beneath Mercury's surface could disclose significant information regarding the planet's primordial atmosphere and conditions that existed billions of years in the past. Looking to the future, excitement is growing for upcoming missions to Mercury. These missions will employ advanced technological innovations to thoroughly investigate both the exterior and interior depths of the planet. With each successive mission, scientists are aiming to uncover more about this mysterious planet and to gain a deeper comprehension of its role in the development of our solar system. Mercury may be a small planet and quite close to the Sun, yet it is truly full of secrets. Exploring its depths not only helps us better understand it, but it could also reveal secrets about how our solar system was formed and has continued to develop. The study of Mercury provides an unparalleled opportunity to investigate the Sun's influence on planets. It is a central theme in the fields of planetary science and exploration. What further discoveries could potentially challenge our present understanding of the solar system? Please share your thoughts in the comments section below. We truly appreciate hearing what's on your mind. Thank you for tuning in, and we look forward to seeing you again soon.